All right, today we are tackling a mystery that has haunted physicists for, 100 years now? It's the quantum reality problem. I mean, what is the world really made of when you get right down to it? The search for that answer? Well, it's led to some of the absolute strangest ideas in all of science. So let's dive in.
So there is no quantum world. Now get this. That quote isn't from some critic trying to tear down quantum physics. No, that's from Niels Bohr, one of its founding fathers. I mean, when one of the pioneers of the quantum world flat out says it isn't real, you know we've got a seriously deep puzzle on our hands.
And that, of course, brings us right to the central question we're tackling today. If this bizarre, spooky realm of quantum mechanics isn't the bedrock of reality, then what is? We're really on a hunt for what the universe is truly made of. And let me tell you, the answer might just force us to rethink everything. And I mean everything we assume about existence itself.
You know, the situation right now among physicists is so wild that some people actually call it a reality marketplace. It's like you can just go and shop for the version of reality you like best. There are dozens of these competing ideas about what quantum mechanics even means. They're all trying to answer that one fundamental question. What's real? It's kind of like we have this perfect scientific theory that's just looking for a worldview to call home.
But what if the problem isn't actually with the physics? I mean, think about it. The math works perfectly. It is, without a doubt, the most successful theory in the history of science. So physicist and philosopher Wolfgang Smith comes along and argues that the whole enigma, this whole mess, it comes from a hidden philosophical assumption, a piece of intellectual baggage that we've all been carrying around for centuries without even knowing it.
Okay, so let's get into the diagnosis of this mystery. According to Smith, the root of all this quantum confusion isn't some 20th century discovery. No. We have to go way back to a 17th century philosophical idea. The culprit, he claims, a man you've probably heard of, René Descartes.
So what did Descartes do? Well, he famously split reality right down the middle. On one side, you have what he called the res extensa, basically the world of things. This is the cold, mathematical, objective universe of physics. A universe with, get this, no color, no sound, no taste. It's all just numbers and equations. And on the other side, the res cogitans, the world of thought. And that's where Descartes shoved everything else, all those qualities, color, sound, taste. So the redness of an apple, he argued it isn't actually in the apple. It's just an experience happening in your mind. This idea, this fundamental split, is the hidden assumption that Wolfgang Smith believes has been poisoning physics from the very beginning.
All right, so if that Cartesian split is the big mistake, what's the fix? Well, this is where Smith proposes something really radical. He says the key isn't to pick a side, the thing side or the thought side. The key is to throw out that split completely and realize that we're dealing with two totally different but, and this is crucial, equally real domains.
So check out this new framework. Instead of Descartes' model, a real mathematical world and an illusory mental one, we get two distinct domains, the corporeal world and the physical universe. The corporeal world is, it's the world of that red billiard ball. It's the world of actual stuff we can see and touch. The physical universe, on the other hand, is what physics measures. It's the cloud of atoms. But here's the absolute key twist. Smith argues this physical universe isn't a world of tiny things, but a realm of pure potential.
So let's really lock in that first definition, the corporeal world. This is the world you and I experience every single day. It's the realm of actual solid things that have real qualities, real color, real texture, real sound. It is not, as Descartes would have us believe, some illusion happening inside our heads. According to this view, our sensory experience is a genuine, authentic encounter with reality itself.
And now for the second piece of the puzzle, the physical universe. This is the domain that science explores with all its instruments and theories. But again, and this is so important, it's not a world of little billiard balls whizzing around. It's a realm of pure potentiality. It's a vast landscape of possibilities, all governed by mathematical laws. Even Werner Heisenberg, another quantum pioneer, said it best. It's a world of potentialities or possibilities rather than one of things and facts.
Okay, so let's pause for a second. We've got these two distinct levels of reality, right? We've got the actual, tangible, corporeal world, and then we have the potential physical universe. Now let's see how this new way of looking at things gives us that big aha moment and actually solves the central puzzle of quantum mechanics.
All right, the weirdest, most argued about thing in all of quantum mechanics has got to be the state vector collapse. Here's the deal.
Before you measure a particle, it exists in what they call a superposition. It's basically a haze, a ghost of multiple possibilities all existing at once. But the very instant you measure it, that whole wave of possibilities just mysteriously collapses into one single, definite reality. The question that's driven physicists crazy is, how? How does that happen?
Think about that. Out of a huge, maybe even infinite number of potential outcomes, the simple act of looking at it, of measuring it, somehow forces a choice. Just one. A single actual result suddenly pops into existence out of this fog of possibilities. That jump, that's what has baffled the smartest people on the planet for 100 years.
But if we use Smith's framework, the mystery pretty much vanishes. Let's just walk through the steps. It's actually pretty simple. So, step 1, a physical system exists as pure potential. It's just a cloud of possibilities hanging out in the physical universe. Step 2, we, from our actual world, perform a measurement. We interact with it. That's the interaction. Step 3, that interaction forces a choice. That's the collapse. A single possibility gets plucked out of that realm of potential. And finally, step 4, that chosen possibility becomes actual. It appears as a concrete, undeniable fact right here in our corporeal world.
So, you see the crucial point here? The collapse isn't some bizarre, spooky event happening within one single universe. It's simply a transition, a move between two different levels of reality. It's nothing more and nothing less than the moment something goes from being merely possible to being fully actual. And when you look at it that way, the paradox just dissolves.
Now look, solving the measurement problem is a massive breakthrough, right? But this framework leads to an implication that is, if you can believe it, even more profound. It forces us to completely rethink the nature of causality itself. It suggests there's a kind of cause and effect that operates completely outside of time.
Okay, so we're all familiar with the normal kind of causality, right? It's what we see every day. It unfolds through time. One domino hits the next domino, which hits the next one. It's a predictable chain. This is what we call horizontal causality. It's the engine of classical physics, a nice, tidy, clockwork universe where the past totally determines the future.
But Smith argues that there's another kind of causality in the game, something he calls vertical causality. Now, this one doesn't unfold through time like a row of dominoes. Instead, it acts on time, from sort of outside of it. It is the instantaneous act of a potential becoming real.
So this vertical causality, this is what bridges the two worlds. Think of it as a form-bestowing act. It's the principle that reaches down into the physical universe, that whole realm of potential, and it selects one single outcome, instantly making it actual, right here in our corporeal world. It's not a process that takes time. It's more like a creative act that happens completely outside of time.
And this, right here, is a radical shift in how we see the universe. It means the universe is not some closed-off clockwork machine that's just ticking along on its own. The state vector collapse, when you look at it this way, is actually evidence that our reality, the reality we experience in time, is constantly being acted upon by a higher, non-temporal cause that is literally bringing potential into being, moment by moment.
Which leaves us with a final and honestly a pretty mind-bending question. If Smith is right, and there's this whole other dimension of causality that we've been completely blind to for centuries, what else are we missing? What other fundamental structures of reality are just lying there, just beyond the reach of our current assumptions, waiting for us to find them? It really makes you think. Maybe the quantum enigma was never just a puzzle to be solved. Maybe it's an invitation to a much, much larger and stranger cosmos than we ever imagined.